Jai Hind everyone. Today we will discuss distributed databases. Before discussing distributed databases, we will discuss about the distributed processing. So distributed system consists of a number of autonomous processing elements that are interconnected by computer networks and cooperate in performing their assigned tasks. So we come across this one word, that is processing element. So this processing element refers to a computing device that can execute a program or a task of its own. Now, question arises, what will be distributed, right? So it may be a function which will be distributed, it may be processing, it may be control which may be distributed, or it may data sometimes. Now come to the definition of the distributed database system. Distributed database is nothing but a collection of multiple logical interrelated databases distributed over a computer network. And the distributed database management system is a software system that permits the management of distributed database. Right. So this diagram shows the distributed database. Here we can see there are three sites, site A, B and C, connected on a network. So data will be spreaded over these multiple computer on different sites. These computer may be known as sites or nodes, right? So these computers are interconnected with the help of this network, and data will be shared by the users on multiple computers, but no sharing of memory or disk among the computer or sites will be there in case of distributed database or distributed computing, but these sites must cooperate with each other for any of the computing and processing. Now, when we talk about the distributed database, it may be homogeneous distributed database or it may be heterogeneous also. So when we say the distributed database is homogeneous, we'll say it is homogeneous when all the sites have identical software, then only we'll say this distributed database is homogeneous. So all the sites must have identical software, okay, and are aware of each other and agree to cooperate in processing user request so that it appears to user as a single system. Now, what is the goal of this homogeneous distributed database? To provide a view of a single database hiding details of distribution, so that the user who are using this distributed database will view all the database as a single database. So all the details of distribution will be hidden from the user. Okay. Now come to the heterogeneous distributed databases. In heterogeneous distributed database, different sites may use different schemas, okay, and softwares, right? So this different schema, different software may create major problem while query processing, and this different software may create a problem while transaction processing. So this heterogeneous distributed databases are very difficult to manage, right? Sites may not be aware of each other and may provide only limited facility for cooperation transaction processing. Now, why this difficulty is there? Because we need to integrate existing databases to provide useful functionality. Our existing database is reside on different sites, and now we want to use it efficiently. Then what will be the way out? Because these sites may have different softwares, these sites may have different schemas on which those databases are having. So Now we need to work on it. So what will be the solution? The solution will be heterogeneous distributed databases. Now there are many protocols by which we will use very efficiently these heterogeneous distributed databases. Okay, these are two concepts regarding the transaction processing. A transaction may be local transaction and it may be global also. So what do you mean by local transaction? Local transaction access data in a single site at which this transaction was initiated. So it is known as local transaction. And what about the global transaction? Global transaction either access data in a site from the one at which the transaction was initiated or access data in several different sites. So such transactions are known as global transactions. So both terms will come across while discussing about the distributed databases. Now distributed data storage, which is our main purpose while we are saying that's distributed database. So we need to store these datas among different sites. So what is our assumption? We are assuming that we are using the relational data model, as we are working on the relational data models in the normal database system also. So similarly, we will work with the distributed databases, right? So first come across, that is the replication. So what do you mean by this replication? We'll understand this replication in detail. For now, the system maintains several identical copies or replicas of data which may stored on different sites. This is called replication, right? And the next term is the fragmentation. The relation, we are having several relation in relational data models. So these relations are partitioned into several fragments stored in distant sites. That is what we are distributing our data among different sites. We are making multiple copies of the same data among different sites so that we can get the advantages of it. We can efficiently use data while one site is down or whatsoever is the failure, right? So this fragmentation and replication can be combined also for getting several benefits. Okay. Now, every technique is having some advantage and disadvantage. So here the fragmentation is also having some advantages. It allows parallel processing on fragmentations on a relation. So multiple users can work parallelly. It allows a relation to be split so that the tuples or attributes are located where they are most frequently accessed. So little overhead of transferring the data among different sites. As it is having some advantages, it is having some disadvantages also. First disadvantage is the communication overhead, right? So whatever the technique we are using, there must be some of the communication. So these overhead will come across. In case data is required from different sides, join have to be performed, obviously. So nothing very disadvantageous. More or less, it is advantageous. Data replication, it is also having many advantages. Things. A relation, a fragment of a relation is said to be replicated if it is stored redundantly in two or more sites, right? So if we are having a relation or a fragment of relation, we may create multiple copies of it on different sites so that if a site is down, we can have that data, the data will be available from different sites to us. When we created a replica, it may be full replication, it may be partial replication. Let's understand what you mean by full replication. Full replication of a relation is a case where the relation is whole relation is stored on all the sites. That is known as full replication, right? And partial replication is where the fragments are replicated at different sites, not whole relation. We create some fragments of that particular relation and those fragments are replicated on different sites, right? Okay. But we need to remember that each side does not contain all the fragments. It will contain some of the fragment only. Here, some advantages of the replication. Availability. Very big advantage of the replication. Failure of some site containing a relation R will not result unavailability of R. If we are having some replicas of this relation R on some other sites. Parallelism. Queries on R may be processed by several nodes in parallel. This is very much required, right? Reduced data transfer. If we are having one copy of that particular relation R locally available on that particular site where the data is required, we need not to transfer that particular relation on that site. So it reduces data transfer. So these are the advantages of replication. Some disadvantages are also there. Increase overhead on updates, obviously. Increase complexity on concurrency control. Concurrency updates on distinct replicas may lead to inconsistency somehow. So it is the responsibility of the concurrency control manager to manage this consistency, right? So more or less these are the advantages of the replicas. Okay. Now come on the data fragmentation, how we can fragment the data. We talk about the fragmentation. We can have several fragmentation of the relation and we can put those fragments on different sites to take the advantages, right? So how we can make the fragmentation, how we can perform the fragmentation. So division of a relation R into some fragments, let's say R1, R2 up to the Rn, which contain different information which contain sufficient information to reconstruct the relation R. So these fragments are mostly of two types, vertical and horizontal fragments. And the combination of this horizontal and vertical fragmentation is the mixed fragmentation, right? So we will understand one by one what you mean by horizontal fragmentation and what you mean by vertical fragmentation. So come on the horizontal fragmentation. Each tuple of R is assigned to one or more fragments, right? So we are taking whole tuple in a fragment. Each tuple of a global relation must be present in at least one fragment. Usually tuples are kept at a site where they may be used most to minimize the data transfer. So we are creating the fragment tuple wise, not attribute wise. So these tuples, when we are making these fragments, we will keep the tuples which are required, most requiredly on the site. We will send that tuple on that particular site to minimize the data transfer. Fragments may be disjoint or sometime overlapped out. Also, as per the requirement, we will create those fragment disjoint or overlapping. So if we require disjoint, so tuple appears in only one fragment, okay, and we require the overlapping, a tuple appears in more than one fragment, right? So as per the requirement, we can have those disjoint fragments or overlapping fragments. Right. So this is the example of the horizontal fragmentation of the account relation, in which in this relation we can see there are three attributes: branch name, account number, balance. So two fragments are created on the branch name. A particular branch name accounts are kept in this fragment, and some other branch name, let's suppose value view, are appeared here in this fragment. So by this way we can create the horizontal fragmentation, and each and every fragment whole tuple is appearing, right? So this is the example of the horizontal fragmentation of account relation. In case horizontal fragmentation, original relation can be reconstructed by taking the union of all the fragments. Let's suppose we are having two fragments in the previous example. So we can take the union of these two so that we can have the whole tuple with us. So by taking union, we can reconstruct the original relation in case of the horizontal fragmentation. Now vertical fragmentation, the schema for the relation R is split into several smaller schemas. So this time the fragmentation will be based on the attribute. Some of the attribute will be appeared in the first fragment and some of the left over attribute will be appeared in the next fragment and so on. So each attribute to be present in at least one fragmentation, one fragment, this is what the requirement, right? So all schemas must contain a common primary key to ensure lossless join property. Whenever we are fragmenting a relation attribute wise, or we say vertical fragmentation, so all the schemas must contain a common primary key. This is what the requirement to ensure the lossless join property. We have already gone through what is the lossless join property, right? If you have not aware about the lossless join property, you may watch that video regarding lossless join property. Okay, so the spatial attribute that the tuple ID here in our example may be added to each schema to serve as the candidate key. So in our example, we are taking this tuple ID in each of the fragment to take a natural join of these two fragments. So let's suppose employee information is a relation that is divided into two fragments, so in which we have taken some of the attribute here regarding the branch name, customer name and tuple ID. Here we are taking some other attributes, let's suppose account number, balance, and tuple ID is common attribute, so that we can construct original relation by taking a natural join. When we will take a natural join, dear students, you already know that we can take a natural join when we are having a common attribute in both of the relation. Then only we will able to take a natural join. So how we will reconstruct that original relation? By taking a natural join of all the fragments. That's why we were having these same tuple ID attribute in both of the table, right? Okay, so the mixed fragmentation is nothing but the combination of both. So horizontal fragmentation allowed by vertical fragmentation followed by horizontal fragmentation. It is nothing but the mesh to take the advantage of both, right? The next concept regarding the distributed database system is the data transparency. Whenever we are creating a distributed database system, we need to have data transparency. Let's suppose we are creating fragments, let's suppose we are creating replicas. So these should be transparent from the users. User need not to see those complexities, right? So this is what the data transparency. It is nothing but a degree to which the system user may remain unaware of detail of how and where the data item are stored in a distributed system, right? So here we are considering these three type of data transparency: fragmentation transparency, replication transparency, and location transparency, right? So fragmentation transparency means what? User will be unaware of how a relation has been fragmented, right? So user is no need to see this complexity, how that fragmentation is created and all, right? So this is nothing but the fragmentation transparency. Replication transparency: users will be unaware of what data object has been replicated and where the replica has been placed, right? So this is none of the user business, how replicas created and where that replicas are residing, on which site these are residing. The user should not know about that. So that replication transparency should be maintained while we are discussing about a distributed database systems, right? Next is the location transparency. User should be unaware of the physical location of the data for the security purpose. Also, when we are working on the distributed database systems, security is the major concern. So location transparency will address the issue of the security. Now, distributed transaction, when we are making databases, these databases, whether these are distributed or not distributed, which are reside on the single site, every time we require those databases for some transaction purposes, right? So why we are saying that distributed transaction? Because our database is reside on different sites. So transactions also need to access data at several sites. Each site has a local transaction manager responsible for. So here, when we are talking about the distributed transaction, two terms are important: transaction manager and transaction coordinator. So what is the responsibility of the transaction manager? Transaction manager is available at each site, right, and is responsible to maintaining a log for recovery purposes so that recovery may be done, and participating in coordinating the concurrent execution of the transaction executing at that site, right? So these two responsibilities are for the local transaction manager. Now, transaction coordinator, each site also has a transaction coordinator which is responsible for starting the execution of the transaction that originate at the site. The second responsibility, distributing sub transactions at appropriate site for execution, and coordinating the termination of each transaction that originate at the site, which may result in the transaction being committed at all sites or aborted at all sites. So these are the responsibility of the transaction coordinators, right? Now, the concurrency control is the major issue when we are discussing about the distributed database system. So concurrency control unit we are using for simple database system will not work here. What we require, we need to have some modification in the concurrency control scheme to use in the distributed environment. Here we will assume for the simplicity that each site participates in the execution of to a commit to ensure global transaction automaticity, and we assume that all replicas of all items are updated. Major problem is in the distributed system when one replica is updated and another remain unupdated. So here we are assuming that all the replicas of all items are updated, right? Now, various approaches to two-phase locking systems are existing here for the distributed databases. They are based on two-phase locking protocols of the centralized database system. So little modifications required for the distributed databases. So the only difference from two-phase locking of the centralized database system, that how the lock manager deals with the replicated data, right? So whatever two-phase locking protocol we are using the centralized database, that will work here also with little modification, that how lock manager will deal with the replicated system. So we'll further address this issue. To address that issue, we will understand what is the single lock manager approach and distributed lock manager approach. So first of all, we will understand the single lock manager approach. The system maintains a single lock manager that reside in a single chosen site, that SI. All locks and unlock requests are made at this site only, SI. When a transaction need to look a data item, it sends a lock request to this site only, SI, and lock manager determines whether a lock can be granted immediately. If yes, the lock manager sends a message to the site which initiated the request. If no, the request is delayed until it can be granted. At that time also, a message will be sent to the initiating site that we are not able to grant the lock, you need to wait for some time, right? Transaction can read a data item from any one of the site at which a replica of the data item resides, right? So whenever a transaction want to read, right, So it may be data item may be read from one of the site, right? So data item is logged in the shared mode at this site. But when we are having write, so write must be performed on all the replicas of the data item. So data item should be logged in exclusive mode on all the sites when it exists, where it exists, right? So this approach is more useful when there is replication, right? So single lock manager approach, when we will use the single lock manager approach when there is a replication, right? What are the advantages of this single lock manager approach? Advantages are the simple implementation and simple deadlock handling. This is another advantage of the single lock manager approach, right? So disadvantages are the bottleneck. The lock manager site become the bottleneck because all the transaction will seek for the permission on a single site, so it may be the bottleneck. And vulnerability, the system is vulnerable to lock manager site failure. If that site is failure containing the lock manager, so it will result the lock of the concurrency control. Okay, so the distributed lock manager is the another category of the lock manager. So distributed lock manager function is distributed over the several sites. Each site maintains a local lock manager. So lock manager at each site administers the lock and unlock requests for those data items that are stored in that site, right? To access a data item not present at that site, request is issued to log the data item to the site SI. If the data item is locked in an incompatible mode, the transaction has to wait till the site SI sends a message that a lock can be granted, else the lock is granted, right? So there are some advantages and disadvantages of the distributed lock manager. So work is distributed, that can be made robust to failure in case of the distributed lock manager. It reduces the bottleneck due to the lock request, which are having the disadvantages of the single lock manager system. Now, disadvantages, deadlock detection is more complicated, obviously. So there may be inner site deadlocks, even there is no deadlock at a single site, right? So it may happen. So these type of deadlock are known as phantom deadlocks, right? So deadlock detection and recovery is very complex here, but we may have the global deadlocks need to system so that we can detect the global deadlocks, right? So there are some of the approaches which may be used in the distributed lock manager. That may be primary copy, majority protocol, bias protocol, and this protocol. So these are some of the variant of this distributed lock manager approach. So in the next lecture, we may discuss these variants in detail. Thank you so much.